This question may or may not be from the TMUA 2024, but certainly if you're struggling with the fact that they haven't released the past papers for the last few years, then this is a good question to look at in preparation. We're given this diagram, and we're told that each square has been rotated 45 degrees and transcribed into the previous square. And we're asked to find the percentage of the largest square that is covered by the shaded square. So the key thing to note here is that to get each new square from the old one, we're using the same process. So over here, let's say this is our starting square. To get the new one, we rotate 45 degrees and we have to scale it down a little bit to fit it into the previous square. If we imagine the next step in the process, sure, our original square is a bit rotated, but it's the exact same thing. In particular, to get from one square to the next, we're going to be multiplying by some area scale factor. And that's going to remain consistent throughout each step of the process, right? Here, sure, we have a rotated original square, but to get to the next one, it's the same idea. And so we have the same scale factor. In total, we do this 2 more times. So we get one more rotated square and one more non-rotated square, which finally is the shaded square in the middle. So that means that if the area scale factor between one square and the next is k, then the scale factor between the outside square, the largest one, and the middle one is going to be k to the power of 4, right? So if we say that this one over here has an area of a, then the area of this middle square is going to be a times k to the power of 4. Now, when it comes to the percentage of the largest square covered by the shaded square, it's going to be the area of the shaded square, which is a times k to the power of 4, divided by the area of the largest square, which is just a. And since we're looking for a percentage, we're going to have to multiply that by 100. So in total, this simplifies to 100 times k to the power of 4. So we'll be able to complete the question as long as we can find k. Now, there are a few ways that you could try to find k. One is perhaps to think about the side lengths of the square. So we could say this first square has side length x. Then these side lengths over here are going to each be x over 2. And we can use Pythagoras to try to figure out the side length of the smaller square, and then we can find the scale factor between the lengths and use that to find the scale factor between the areas. But there's a really fast way. Let's think about our original square. I'll redraw this diagram. And we have our rotated square inside. It's been rotated by 45 degrees, which means we have these 2 lines of symmetry over here. And these divide the original square into 4 smaller squares. And the diagonals of this rotated square here form the diagonals of each of the smaller squares. In particular, these diagonals are cutting each of these squares into halves. So you can see in total, these regions that make up the rotated square are actually taking up half of the area of the bigger square. And that means that the scale factor between the 2 areas is going to be a half. So we have k equals a half. Now it just remains to explicitly calculate this expression over here, 100k to the power of 4. So that's going to be 100 times a half to the power of 4, which is 1 over 16. And when it comes to simplifying fractions quickly, it's often good to think about factors and prime factorizations. So 100 is 10 squared, and 10 is 2 times 5. So this 100 we can write as 4 times 25. And 16 is just 4 times 4. So this 1 over 16 is 1 over 4 times 4. We can see that these 2 4s over here cancel, and we're left with 25 over 4, which is 6¼ which is 6.25, which gives us a final answer of A. Thank you so much for watching. I hope you enjoyed, and I'll catch you all in the next one.